Okay, so as I said in the previous video, the most important topic in this chapter is the standard deviation, or equivalently the variance. So from now on, we are going to define the variance and study properties of them. Let's start from the basic idea. We are measuring how much observations deviate from the center, how much observations are far from the center, the distance. That is what we are going to measure, what we want to measure, right? So first, then we have to define the center, which is easy. We are going to use the mean, right? So mean is the center. Then it remains to measure the distance, right? We are going to define deviation of an observation in this way. Just observation minus the mean. That is the difference. That's the distance, right? How far the difference between observation and the mean. That is the deviation. So let's now think about another example. We will simplify our investment example. There is a you are investing, you bought a like stock or say lottery, and there are three possible outcomes. You may lose $10 or nothing, or you may earn $20. And the probabilities are like this: 20%, 40%, 40%. So simple financial investment. And from here, try to find the expected return. It's a simple exercise. The first step, okay, so to calculate the expectation, remember you have to make another column, weighted outcome, probability weighted outcome. So multiply outcome to probability minus 10 times 0.2 and 0 times 0.4 plus 20 times 0.4 and sum those probability weighted outcomes. Then if you do that, you get 6. So on average, you are going to earn $6 from this investment. Okay, that is easy. So now we get the center. 6 is the center. And let's calculate the deviation from the center. So if the realization is minus 10, then that is $16 below your expectation. Minus 16 is the deviation. And if you earn 0, then it is $6 lower than your expectation. Plus 20 is $14 greater above your expectation. So you get deviations in that way, and interpretation is straightforward, right? How, like, given the expectation, how much you earn more or less, right? Or how far from the center. And one thing I want you to observe here is this is a transformation. So from the original outcome, gain or loss, from the original outcome, you are calculating a new random variable. It is a transformation of the random variable, which we practiced in the previous chapter. In our previous chapter, we learned you can transform random variables to get more interesting or more important random variables. Exactly, we are doing that. Instead of the outcome itself, we are interested in the distance. So we have to transform the random variable to define a new measure. And then the problem here is we want a distance. However, deviations are not exactly a distance because it is negative. So two of them are negative. So a distance cannot be negative. I understand the absolute value is a kind of distance. So what we are going to do here is we are going to square them. Take squares of the deviations, and then you get squared deviations like these, and they are all positive, of course. When you square a number, square a negative number, the result will be positive. So you get square deviations, and we are going to treat the square deviations as a distance, right? All positive, and it is larger. The number is larger if the outcome is further from the mean. So exactly that is a distance. The greater the square deviation, the further away from the mean. So, and then it is a new random variable we wanted. We wanted a distance. Exactly, square deviation is the new random variable. And then what we are going to do is just make another probability table for the new random variable and calculate the mean. The mean, its mean is the variance. We define the variance as the mean of the squared deviations, right? So if we write it down, it is obvious. We take deviations, we define deviations, and then square them, and then take their mean, excuse me. So that's the result. The way you calculate the variance is exactly same as the way you calculate the mean, right? Square deviations are, again, new random variable. So these are outcomes, right? And multiply those outcome with the respective probability. So 256 times 0.2 is the probability weighted outcome for this new random variable. Likewise, calculate them and sum all the numbers, you get 144. That is the variance. Okay, so this is how we define the variance. And let me summarize. Mathematically, you can write it this way. So x is outcome, subtract the mean. So x minus expectation of x is the deviation. And then you square it and then take expectation. Okay, so subtract mean, take square, and take expectation. That's how you calculate the mean. And its interpretation is clear because squared deviations are distances. So variance is on average distance, right? So it is an expectation of distance, so average distance. And of course, the larger the variance is, the more variation in data, right? So that is pretty straightforward in our definition and example. Okay, so then let me give you an exercise. So the definition was clear. Now what I'm going to do is we consider the same investment, but actually there was $1 investment fee, or say tax. So when you calculate the gain and loss, you have to take this into account. The say fee, $1 fee applies to your final outcome. So when you lose $10, actually you are losing $11, right? 0 was actually -1, and even if you earn $20, you have to pay $1 as a fee. So the outcomes are subtracted by $1 fee, net of fee, and then it's your exercise to find the variance of this investment return after netting out the fee. Pause the video and try to calculate the variance step by step. If you need help, you may go to the previous slide to pick how to do it. So it's just practice and exercise. Okay, so let me give you the answer. First, you have to calculate the mean because you have to capture the center. And the mean would be changed because you subtracted 1. The way you calculate the mean is the same, but as a result, you get 5. And if you are clever, if you are smart, you don't need to do this calculation because you are subtracting -1 from everywhere. So the mean would be also subtracted by 1. And the previous original example had mean of 6, so now it must have 5. So it's clear. And then calculate the deviations first. So gain like the outcome minus the mean 5 and square them, square deviations. So what I want you to note here is these numbers, deviations, are actually the same. So minus 16 minus 6 plus 14. This is the same number as you have here. This is our original example. Original example, minus 10, 0, 20. And then you get deviations like this. But even if you subtracted 1, the deviation does not change. That's because all the outcomes move by minus 1, shifted by minus 1. And the mean is also moving in the same direction by the same distance. So everything moves by 1. So their difference does not change. Deviation is the difference. So if two things move, shift by the same direction, in the same direction, by the same distance, their distance does not change. So square deviation does not change, which is intuitive. If you understand this as a distance, like minus 1, does not change the distance at all because everything moves parallel, like it's just a shift. Okay, then the variance should be the same. Square deviation is the same, so variance must be the same. You do not need to do this again. They're basically the same algebra. Okay, so then now I will have you do this. Like I'm going to finish this video now with this question. So you are going to do like after this video, try to do this question and start the next video after you finish this question. Now what I'm going to consider is, instead of paying fees now, what I'm changing here is I am scaling up the investment by 10 times. Like instead of buying 1 stock, you bought 3 stocks, for example, or playing lottery like 10 times. So the new random variable has 10 times larger losses and 10 times greater gain. So with the same probability. In this case, what is the variance? Do the algebra. I'm going to come back in the next video. Okay, bye. Thank you for watching.